Okay, good morning, guys. What we're going to check out this week is a different type of logarithm than we've seen in the past. What we've looked at up till now is logs with any given base that is a number. But now we're going to check out a base with a letter. Okay? But this letter actually represents something. Okay? This letter is going to be E, and it represents an irrational number, kind of like how pi represents 3.14 and so on. E is similar to that. The number that E represents is 2.71828, and because it's irrational, it's just going to keep going on and on and on. Okay, so the reason this guy even exists is because it pops up pretty often in real-world scenarios, and we're going to check out how that can be used in just a little bit. Okay, so when we have an exponential term with E as its base, we call that the natural base. And that would look something like this if we had like f of x equals e to the x power. If we have a logarithm with e as its base, we call that a natural logarithm. And that's when, like I said, we have e as its base. But so just so we don't have to always rewrite with e as the base all the time, we actually have another way of writing it. We do a little ln. Okay, so whenever you see this ln of x, which stands for log natural, which is weird because it's Latin, so that's why it's kind of the reverse of natural log. But this guy is just going to be having a base of e. So now let's go ahead and try and do all the same things we've been doing with logs, but now with this natural logarithm. So first off, let's write each equation in logarithmic form. So remember in the past we had something like this. If we had log base b of a equals x, we were able to convert that into something that looked like this: b to the x power equals a. We're going to do the same thing now, but instead of a log, we're going to use a natural log because our base was e. So in this case, we're just going to go ahead and say the natural log of 24 equals x. So the same idea. So for this guy, we'd say the natural log of x equals 9. For this one right here, we'd say the natural log of 72 is equal to x plus 5. And that's how we can convert when we have these natural bases. Okay? We can also go in the other direction. Remember, when you see this ln here, okay, that just means that it's a log with a base of e. So this one I would do e to the 58th power equals x. For this one I would do e to the x power equals 6. And for this one I would do e to the 32nd equals x minus 9. So when it comes to using our log properties, all of them still apply. We just have to make sure that we're looking at these guys and going ahead and realizing that they have to both be that natural log for us to be able to use those properties. So for number 7, we're separated with addition. We can combine this into a single log by using multiplication. So this is just going to be 3 times 16, natural log of 48. Remember, you can only use these logarithmic properties when you have no coefficient in front. So I'm going to go ahead, and for this guy, I'm going to move that 2 into my exponent. That's 3 squared, or 9. And then because there's subtraction here, I combine into a single log with division. And I end up getting the natural log of 7. Always keep in mind that we also have fractional exponents that can have an effect here. So in this case, I'm taking each of my coefficients to start off, and I'm putting them in as my exponents. And then what I can do here is 64 to the 1/3 power over root. This is really just the third root of 64, or the cubed root of 64. Cubed root of 64 is 4. And then here we got natural log x squared. There's addition in between them, so I combine them with multiplication. And we can also work in the opposite direction. So for 7, 8, and 9, we condensed. We took multiple logs and combined them into a single log. we can also break things apart. For example, if we have the natural log of 5x, that's the same thing as the 5 times x, right? So I can break it up into the natural log of 5 plus the natural log of x. I'm going to break it up with addition. For this guy, first I'm going to go ahead and give that exponent to both my numerator and denominator. And then, because there's division here, I can separate it with subtraction. And then to finish off, I'm actually going to go ahead and take these guys and put them out in front using my product, or sorry, my power property. Excuse me. And then for number 12, you had to get a little clever here. Because we had the cubed root, right, we don't have any exponents for both these guys. We just have it for that squared. But if we just think power over root, we can actually rewrite these. M is being raised to the second power, and it's also having the cubed root taken of it, so that's going to be to the 2/3 power. N only has a power of 1, and I'll just do 1/3 power. Then I'd be able to separate these guys with an addition sign because they're being multiplied together. And then pull my exponents out in front to get my final answer. So all of our log properties still work, even when we're dealing with the natural log. Right? So the natural log come in handy when we're looking at some specific types of equations. Right? When we're just dealing with a natural log on both sides, nothing changes. Remember, in the past, if we had a log on both sides, we were able to ignore those logs and just set these guys equal. And then it's pretty easy to solve this out. I add 2x. I'm going to go ahead and add 27 to both sides. And that'll give me 42. And divide by 6. And I get my answer, right? Remember, you still got to go ahead and do that little check, which means that you're going to go ahead and look into these guys and make sure that you're not getting the log of a negative number at all. 4 times 7 is 28, minus 27, that's 1. Looks like we're good. Right? And then for ones like 14, just make sure that you can't go ahead and rewrite these guys until you get rid of those coefficients. So I'm going to pull that 2 out in front and get something like this. And now that both my sides just have natural log in front, I can just get rid of the natural log. Hey, this looks like it's a quadratic. Remember, when you see something, a variable squared, that's quadratic. So what I'm going to do is I'm going to go ahead and get everything equal to 0, and then I'm going to factor. Remember, factoring is where we're looking for two numbers that multiply to negative 15 and combine to negative 2. That's going to be negative 5 and positive 3. And then I set each of these equal to 0 and solve them. And I get answers of k equals 5 and k equals negative 3. Right? Make sure you go ahead and you plug those in and check to see if they work. Remember, that means that you shouldn't be taking the log of a negative number. If I plug negative 3 in, it looks like I am, so that's going to be gone. When I plug 5 in, it looks like I'm good. So 5 would be my only answer. Right? And then also you got to make sure that you use your log properties when necessary. For number 15, you'll notice that we have a bunch of logs on both sides. We want just a single log on either side. So first off, this guy, I see that subtraction. I can combine that with division, right? On this other side, I have addition. I can combine that with multiplication. So it looks like 72 over 4, that's going to be 18 equals, this is going to be 6a minus 12. So I got rid of the logs because now I had a single one on each side. All I got to do to solve is add 12 and divide by 6, and I get 5. Okay, do a quick check, make sure that you don't have to take the log of a negative. Looks like we're all good. Okay, and when we don't have logs on either side, okay, then we can rewrite an exponential form to solve these guys. For example, number 17, you'll see we only have a natural log on the left side, nothing on the right. So in these scenarios, what we can do is we can rewrite it in exponential form. Remember, that's just our base, which the base of natural log is always e, so it's going to be e squared equals 8x. All I have to do to solve is divide by 8. Right? So what we have to remember here is that e is actually a number, right? It was like 2.718, all that good stuff. So we can actually get to that number really easily in our calculator. Right? If you just press second and then go down to this ln here, it'll give you e raised to a power. So to get my answer here, I'm going to do e squared, and then I'm going to divide that by 8. So I got an answer of 0.9236. Okay? If you don't have a graphing calculator at home, go ahead and just go into Google and type in calculator, and it will give you the ability to raise e to any power you need to. Okay, so let's look at another one. Remember, sometimes like in 18, you're going to have to use our log properties to get started. So this guy, because we're subtracting, we combine it into a single log with division. Okay, and now that we have that single log there, just on one side, we can rewrite in exponential form. It's going to be e, our base is e, to the 7th power equals x over 9. To get x by itself, I'm going to multiply by 9. And then I'm going to do 9 times e to the 7th. And it looks like I get 9,869.6984. And then we can also solve exponential equations by using the natural log. The times that we're going to use the natural log instead of our common log are if we notice there's a base of e. So for number 19, we have e to the x power equals 57. The way we would solve this guy is we'd first isolate our exponential term, which is already done, and then we're going to take the natural log of both sides. Remember, what this gives us the ability to do is take our exponent and pull it out in front by using our power property. Okay, the nice thing about this is we can divide by the natural log of e, but what you'll notice is when we do the natural log of e, check it out. Natural log of, I'm just going to do e to the first power here. It just gives us 1. Okay, so the natural log of e is equal to 1. So right here, this guy was just 1. We don't even really have to worry about it. What we would do to get our answer here is just the natural log of 57, and we get 4.0431, and we're good to go. Okay, so let's look at one more where it's a little more complex. If you take a look at 22 here, right, all we're doing here is isolating first. In 19 we were already isolated, but here we're going to have to subtract 3 and then go ahead and divide by 2. And now, once we're isolated, we take the natural log of both sides. So I'm going to do natural log on both sides. What it gives me the ability to do is take this c minus 9 and pull it out in front. But remember, something good happened here. The natural log of e is actually 1, so we don't even have to worry about that. All we have to do is add 9 to both sides, and I'm going to go ahead in my calculator and do the natural log of 42, and I'm going to add 9 to it. Looks like it gave me something like 12.7377, and I got my answer. So what I'd like you guys to do on the next 2 pages, I want you to do the odds. Okay, so it's all log stuff, but so the same as what we've done in the past, but now we're looking at the natural log. So you're going to see ln all over the place. And remember, you can find ln and e on the Google calculator if you don't have a graphing calculator. I hope you guys have a good day.